To draw a Fischer projection, you start with a staggered side view of a molecule and then make that ellipsed, then draw the ellipsed top view, and then the Fischer projection. And you can go back and forth between these drawings. The molecule I'm going to draw is 3-chloro-2-pentanol. This is my OH group, this is the chlorine, and this is the 5-carbon chain. This is carbon 2 and carbon 3. Because carbon 2 and carbon 3 are chiral, when I draw the molecule, I'm going to condense everything else so that I only focus on the bonds around the chiral carbons. Okay, looking at the molecule, the chlorine is pointing towards us, so it will be the wedge. The hydrogen is pointing away. On carbon 2, the OH group is pointing towards us, and the hydrogen is pointing away. So this would be the staggered side view of the molecule, and it is the regular way that you would draw a molecule. And staggered, of course, means looking down the carbon 2, carbon 3 bond. This would be a Newman projection, and all the other bonds are staggered to each other. They are 60 degrees apart from each one. So the next step to getting to a Fischer projection would be rotating this bond and making it eclipsed. What I mean by that is rotating the molecule so that when you look down, carbon 2, carbon 3 bond, the other bonds lay on top of each other, and that would be eclipse. So now we're going to draw this. Okay, so when you do that, one half of the molecule stays the same because you're only moving one side. In this case, I kept the left side of the molecule the same. And when I turned it, notice that originally the OH group was pointing towards us. Now it's pointing away, so it will be the dashed line. The hydrogen gets the wedge. Okay, so this is the eclipsed side view. The next step to a Fischer projection would be the top view of the eclipsed molecule. So imagine looking down at the molecule like this, and let's make this be the top and this be the bottom of the molecule, so that basically we're going to be turning it and looking down on it this way. Okay, so the CH3 group is now going to be the top. The ethyl group will be the bottom. And since I made this the top and this the bottom, that puts the hydrogen and the chlorine on my right side and the OH and this hydrogen on my left side. So it doesn't matter which side you do, just choose a side and keep them the same. And then this would be how the model looks, like this. Carbon 2, carbon 3, this is the chlorine, the hydrogen, and this is the OH group and the hydrogen. So just going from a side view, eclipsed, to top view. Now, the Fischer projection is this drawing, except all the lines are solid lines. So, a Fischer projection is a flattened top view of an eclipsed molecule. So this is the Fischer projection, and notice that in the real molecule, OH and chlorine are on the same side. And it's because that they're staggered at this point in the Newman projection, but when we change it to eclipsed so that we can draw the Fischer projection, they end up being on the opposite sides. So that is why the Fischer projection shows them on the opposite side. So don't let seeing the groups on opposite sides mean that they'd be on opposite sides in the real molecule, because they're not. And that's how you draw a Fischer projection.